hello, and welcome to the show. It is me, JP. It is time for JP's Product Pick of the Week. Thank you so much for stopping by and hanging out with me and Lars here, who's busily typing away on his computer or something. We're going to spend the next, 20 minutes or so checking out a cool new product, doing a little demo, give you a tour of it, and the first thing I'll do, in fact, is let you know where to get it. So that URL right there, or that QR code, if you're into that sort of thing, that will take you to the product page for this week's product pick, where we have a deep discount going on live. All you've got to do is buy it during the show, and you'll get the discount. There's no coupon code necessary. And we've got a maximum of 10 per customer, no resellers allowed. We also don't take back orders or rain checks or things like that. So if you want to get them, because if they sell out, then we don't have any more, and you don't get the great price. Price goes back up after the show, by the way. So that is where to go check it out. I want to thank everyone for stopping by over in YouTube. We've got Robert Cochran. Hello, Robert. Hello to Beata Graf of Del Hagen, Dave Odessa, Tyrone Mix, hello, and Zoe Sherry, howdy. The graphic was seriously creeping me out. Yeah, me too. But I have no apologies. Because look, you just cut that out, and if you need a Halloween idea, you can go as me. If you do, let me know. I want to see that. And we've got our Discord chat. So if you're somewhere else like Facebook and you're looking around and it seems very empty, well, check out our Discord. This is a cool place. Discord server is at adafruit.it/Discord. You'll get an instant invite. Hop on over to the server. Look for that channel right there. That's the live broadcast chat channel. Hello to Paul Cutler there. John Nodge, Sam J. Ohio, Thin Man, DK, howdy. Todd Bott. Lars is in the HDMI corner of shame. Poor Lars. I don't know what he did to get himself there. So Burton Rutan in the chat says, it's fun to try to guess the product from the thumbnail. If you haven't guessed by now, what I'll do is have Lady Ada tell you all about it from her new segment on Ask an Engineer. So please take it away, Lady Ada.
A really nice I2S DAC built on the PCM 5122. This I2S, this digital DAC chip, is used on, I think, the Hi-Fi Berry and some other, Raspberry Pi bonnets and stuff. But it's also, what I really like about this I2S DAC is it's, digital in. So you've got down here, power ground, and then the I2S, W select, DN, B clock. M clock is optional. You do not need to give it a M clock signal, which means it works great with any microcontroller that does I2S, because a lot of them don't generate M clock. It has a digital mute and line out left and right stereo. And you don't need to use it. You don't have to configure it. Like, if you want, you can use it in a hardware mode where you just give it I2S and audio comes out. And you can use some of these pins to set the gain, but for the, in the format. But for the most part, it's like plug and play. Like, you just give it, power, ground, and 3 digital signals, and audio just starts piping out. And then you use mute to do a digital mute. But if you want to have configuration like volume, and I think like there's some digital like DSP filter stuff inside, and soft mute, and other like filters and de-emphasis, and changing the like offset gain or whatever, there's I2C and SPI available, and we wrote drivers for again Arduino and Python/CircuitPython if you want to use the control pins in order to do software control of the I2S decoding. But like I said, I really like it that it's a really high quality I2S amp, and it works with everything because you don't need to do the configuration. It works like out of the box.
Hey, yes, that's right. That right there is the product pick of the week this week. It is the PCM 5122 I2S DAC with hardware I2C and SPI control. Phew! So this is a stereo DAC. We have a 3.5 millimeter TRS, tip ring sleeve connector on there that gives you stereo output at the line level, which means you can plug this into powered speakers, you can plug this into an amplifier. This is a pretty typical type of output level to want so that you can then really power it with a big amp. This comes out at line level, so it's perfect for that type of usage. You're not going to drive big headphones with it. You're not going to drive speakers directly with it. You are going to go through some kind of an amp. And also, not only do we have, let me bring up the little picture here. Not only do we have the output on there for plugging in your typical 3.5 millimeter cable, but we also have some pads that you can solder directly to if you want to get the left out, right out ground off of those bottom pins there. This is for digital audio, so you'll use this with things like pretty much any microcontroller, but especially great for stuff that doesn't have a DAC that you can use easily. Things like RP2350, ESP32 for Raspberry Pi. This is a really great DAC for that. These are designed for things, if you look at the data sheet, I'll take a look at that with you in a second. This is designed for audio equipment. So this is a Texas Instruments chip. It's designed for things like audio AR receivers, Blu-ray players, and other audio applications they mentioned. It is fully featured, and like Lady Ada said, you can configure this with digital pins to do just simple stuff, but the real power from this comes with the control over I2C, in particular, in the drivers that we have for CircuitPython, for Arduino, that allow you to do things like adjust the gain per channel, so you can do things like your own panning mixes. You can mute from from software. You can also do things like establish your own fade out. If you want to have a button you hit that will fade this audio down or do a crossfade, you can do all of that in software. And I'll show you a little demo that gives an idea of some of those things in a second. So let's go to the product page right there. So there you can see it's product ID 6421. And we've got it right now at $3.75. So maybe pick up a couple if you have some ideas for some audio projects with this. And in fact, let me throw my little overlay there, which I can see the stock count. We're having a refresh. So as you can see here, the stock, we started with 100. We've gone down to 78 of them. So pick them up now if you want to get them. They are, as you can see here, there's a bunch of details on this about noise floor, decibel rating, the anti-aliasing filter that's available with de-emphasis, attenuation and gain that you can adjust with pins or with software, as I mentioned. If you keep scrolling down, you'll get to a link to the main Learn guide that Liz put together. Thanks for putting that together, Liz. So there, once again, you can see we have all of the inputs necessary to connect this up to 3 pins that you'll use for I2S digital audio, as well as power and ground. And then the control necessary for SPI and I2C. So as you can see at the bottom here, we have the left and right out, ground, mute pin if you want to do that with hardware. Word clock, word select, and D in, I think, are the 3 pins that you'll hook up. We'll take a look at that wiring. And then across the top here, we've got, if you want to use SPI or if you want to use I2C, you have the serial digital and serial clock for I2C. And then if you keep going down, you've got a link to pinouts here. A little info about those. So let's see, what was I wondering about with I2S address pins for I2C. Let's see, where's the I2S pin? There we go. Word select, DIN, data in, and bit clock. And you don't need the main clock. That is optional. So then we have links here, pages within the guide for setting it up for hardware mode. So this would just be simple digital in-out pins to just change some of these configurations. But you can't do as fancy of stuff such as the fading of gain, cross-fading, panning, that kind of stuff. So what I recommend is check this out, either in Arduino or CircuitPython, this I2C mode. And I believe while this has SPI access, I don't think our drivers, maybe the Arduino one does, but I don't think the CircuitPython driver discusses using SPI mode, and I'm not sure in what case you'd need that, but the I2C works great. So here is a typical wiring. That's the same wiring that I've got in my demo that I'll show you in a second. and it's going to a Feather in this case, Feather RP 2040. I think that's what I have too. Yeah, RP 2040. And so if we take a look at this original one here, you can see I2C at the top there, connected I2S for digital audio, and then power and ground, and then our output. So let's take a look at and listen to a demo. I'm gonna switch over to, I'll show you at full view here for a second. Oh, and let me tweak that camera a little bit. Let me goose that exposure up a nice bit, and it's looking kind of warm. So let's cool that off a bit. There, that's a little better. I found this funky translucent breadboard in a box the other day and decided to use that. Be fun to point some LEDs at that thing. Let me go to focus and see if we're as focused as can be. There we go, that's nice and sharp. So I'll go now to, okay, so you can see here I've got the Feather, I've got the PCM 5122, and then I've got it connected on I2S and I2C for control. And then I have this 3.5 millimeter cable going out. That's actually going to my mixer, and I have some monitors, so hopefully you'll be able to hear it, I'll be able to hear it. And this is one of the things that I'll demonstrate is stereo panning. So if you have a pair of stereo speakers on your computer or some headphones, you'll be able to hear that a little better than a mono speaker or just a single speaker on a monitor. So let's go to that view right there. Okay, and I'll take that off for a second. Let me bring up Zed. So here I have a little sample that I created in CircuitPython. And what this is going to do is I've got 3 modes. We'll be able to just listen to the audio, and I can show you changing manually, changing some gain values, some volume. I've got a panning demo that'll pan left and right. And I've got a muting demo. And this is all going to play an MP3. So you'll see here I've got audio IO, or audio.mp3, audio bus IO. All of those are so that I'll be able to play this MP3 over the I2S audio. So here we've got the library for the PCM 51XX series, so I import that, set up I2C, and then I'm creating the DAC object. DAC equals Adafruit PCM51XX.PCM51XX on the I2C bus. And then I'm going to set the volume. So I'm going to say DAC.VolumeDB, and then I just give it a left and a right channel for the stereo, left and right channel volume. So decibels essentially works as 0 being our kind of maximum volume, and everything less than that being a quieter, lower volume level. So this is how we set volume. You can also query the volume. So if you have a need in your code to ask the DAC, hey, what volume are you at right now? You can use this DAC.VolumeDB. Just ask it. And in this case, I'm casting these 2 variables, left and right dB, to be the answer to whatever that's at. And then I'm printing that out. You can mute and unmute with DAC.mute, false or true. So true, it's going to be muted. False, you're going to be able to hear it unmuted. Here I'm setting up audio as audio bus IO on the I2S output. That's the very high quality digital audio output, and I'm setting that up on 3 pins, D9, D10, and D11 on my Feather. Then I'm opening up this BartleBeats MP3, setting up the MP3 decoder for that file, and then telling the audio play MP3 and just set it in a loop. So it's just playing, and it's playing right now. You won't hear it because I've set the volume to 0 in the demo right now. So here I've got a couple things for the demo, max dB and minimum dB. So max will go up to -3, minimum -45. You shouldn't be able to hear it at that level. How many steps I'm using to do the crossfade, and how much delay in those. So this is, I think, a nice sounding crossfade that you'll hear pan left and right as I bring one up and the other down, and vice versa. So my demo right now is just set to play. So I'll go ahead and set the DAC level to -4 and hit, oh, It's going to give me a problem with trying to save. Hold on. Let me unplug and replug. Let's see if it shows up. Good sign. I should probably reset as well, but let's see. There we go. So let me know how the level is. I've got mixer control of both microphone and audio. You will hear, by the way, the USB mounting noise, error, restart that always happens in these demos. Sorry about that. Once it's running, it'll run fine, but after you save, a few seconds after, the USB kind of catches up. And this will kick into some drums and things so that you can hear a little better. Okay, so I'll just wait a moment while that plays. So this is at -4 dB. It should be fairly loud. I didn't want to drown out the microphone, so let me know, and then I can boost that or lower that as necessary. In the meantime, I'll say you can see here when I do start it, it initializes the PCM5122, sets the volume initially at -8 dB, then I unmute it to make sure that you're going to hear it, and then since I set the volume here to be -4 on left and right, I then print that. Okay, I got the thumbs up from Todd, and Dave Odessa says fairly loud. Great. So now what I'll do is I'm going to change the, let me just manually change these. So I'm going to get the left channel out of it. Hit save, and now you'll hear, if you have headphones on or if you have stereo speakers, you'll hear that just in one ear. Oh, I wasn't changing the level, actually. Give that a little boost there. I was just changing my monitor level. So this I'm only hearing that in the left. So left and right, I have left at -4, I have right at -48. Okay, get that to that point. So you should only hear this in one ear now. Now what I'll do is change this to my second demo, and in this is this pan demo. What's going to happen is I'm going to increase one while I decrease the other, hold for half a second, and then go the other way. So I'll save that. And USB will, oh, that's the wrong one. Why is that demo? What did I break? Why is that the muting demo? It should not be that, hold on. Oh, that's why. I changed the wrong thing. Okay, here we go. So that's in my right, left, right, left. I'll let that get to a better part of the song. I should have edited this or told the MP3 to start where it's a little more active. Oh no, USB is going to make a restart. Okay, I'll let this play. You could, of course, set this to be based on a control if you wanted a potentiometer or an encoder or something like that, interpret that in CircuitPython or in Arduino, and then send these same commands, these DAC.volume_dB, to be able to crossfade yourself. It doesn't have to just be sort of running automatically. And like I said before, while we have hard mute, and I'll demonstrate that, you could also have a fade out. If you wanted a button that just takes 2 seconds to fade out instead of an abrupt stop, that's the kind of thing that this I2C or SPI control is perfect for in code. Okay, so I'm going to change this to my demo 2, which is this muting demo. And here you can see I've just got song is looping. USB will restart probably. But every half a second, DAC.mute is false, DAC.mute is true. DAC.false is true. DAC.mute is false, DAC.mute is true. Okay, and I'll set that just stop the code running there. Okay, so I think I'll turn that down just to reduce noise. Yeah, I hope that all worked. That was actually a good test of the new mixer I got to be able to do some of that stuff without feeding my mic audio back through, but monitoring that. So yay. So you can tell, I really love this DAC. I think it's excellent. It's a good choice for using software control over this digital I2S audio. Let me go over to Discord. There was a question in the chat here from DK. How does this compare to the TLV 320? Todd answered, thank you. TLV 320 DAC has both a speaker amp and a headphone line-out driver, and its I2C controllable mixer to deal with a couple of analog inputs, as well as the DAC audio. TLV 320 AIC is a codec, ADAC and DAC, and really powerful. So hopefully that answers your question. It just depends on your needs. Another question from the YouTube is from Tyrone Mix. Is it a digital out or an analog out? This is an analog output at the jack, just to be clear. So that right there. Let me zoom way in. If I can get the focus to agree. There we go. So this right here, this is analog output. So are those two pins, L out, R out right there. So digital audio converter, DAC, that is taking the digital I2S output that the microcontroller can send, and this converts that into analog AC coupled audio. So it's standard run-of-the-mill line-out level audio that you'd plug into any kind of powered speaker, receiver, mixer, anything with that's expecting a line level, which is what like an MP3 player or your iPhone is putting out. If you plug in the old days, used to, before Bluetooth, plug your aux cable. This is that level. Let's see, are there any other questions? John Nutch says the translucent breadboard seems very 80s somehow. I think it yellowed over the years, sadly. Maybe I'll retro bright that. Let's see, are there any questions in the chat? Oh, the autograph of the Hagen said, fun breadboard anecdote. I bought a display 2-pack of this one time. One of them was badly yellowed. The package was sealed. That's weird. must have been displayed with something covering one of them. Yeah, that's probably sunlight damage to get it yellowed like that. All right. Well, let's see. I did mention I would show you our downloads page in the main guide, and if you come here, you'll see there's this link to the PCM 5122 datasheet, and that's the PDF. Let me zoom in on that from Texas Instruments with a bunch of salient info. It accepts 16, 20, 24, and 32-bit audio data, so very high resolution, high quality audio. There's the noise floors listed there, and 384 kilohertz PCM interface. So high quality, fast, no aliasing. Applications I mentioned: AV receivers, DVD, Blu-ray, BD, Blu-ray disc players, HD TV receivers, and more. So there you go. I think that should do it. Let's see how we're doing on sales. Hey, we've sold a bunch of them, so I look forward to hearing what you use them for. Again, I'll mention this runs off of I think both 5 volt and 3 volt. Let's check. We should have that in the pinout. 3.3 to 5 volts. The data lines are 3.3 volt logic. So use this with modern microcontrollers that are 3 volt. That'll be the easiest thing. And you can use this for all sorts of audio projects. They can be wearable. They can be prop based. They can be desktop stuff. It's great to pair with your microcontroller to get really nice audio out. All right, that is going to do it then. That right there is my product pick of the week this week. It is the PCM 5122 I2S DAC with hardware, I2C, and SPI control. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you next time. Bye-bye.